Kia ora Year 12 and 13. This video is inspired by a true story of my lunch today. So I got to the end of the day and I hadn't had a chance to have any food and left school very, very hungry. So I drove up to my favourite after school place, which is just off the Wellington College bus, by the way, Gyp Street Deli. They make the best pies. And here it is, one of their lovely steak and mushroom pies. Unfortunately, the guy who heated it up did a really, really good job, and he heated it up so that it was 100 degrees. So just looking at that COVID tracker date stamp, you can see that I got in there at 4:11 p.m. Let's just say that I got out of there at 4:11 p.m. as well. So my pie is 100 degrees and I can't eat it. I was really sad. I decided that I would go home, so I drove home. My car was 18 degrees and my house also was 18 degrees, very conveniently. And I got home and I got the thermometer out. Actually, that's a lie, I made it up. And the pie was still too hot. It was 88 degrees, and that was after 5 minutes. I went on Google to figure out when the pie would be good to eat, and I discovered that it was at about 70 degrees. That's from cookingstackexchange.com. So let's figure out, when did I get to eat the pie? Now, you're sitting there going, this is really stupid, but this is a really standard Merit Level 3 integration problem, and if you're really lucky, maybe an excellence one. So Newton's law of cooling says the rate at which the temperature changes is proportional to the difference between the temperature of the pie and the temperature of its surroundings. So we're going to go right from the start with this and write the differential equation and then go through and solve it. First, we're going to get a general solution, and then we're going to get a particular solution for these values. Right? So we've got dt by dt is proportional to the difference between the pie temperature, big T, and the surrounding temperature of both the car and the house. So we can write that as dt by dt is equal to k times t minus 18. All right, let's separate the variables. Well, we've got 1 over t minus 18 integrated with respect to t is equal to k times dt. Integrating both sides, what do I get? Well, on this side I've got the natural log of t minus 18, and on this side I've got kt plus c. Let's do e to both sides. That gives me t minus 18 is equal to e kt plus c. I'm going to split this up into 2 bits. I'm going really fast with this because if you're watching this, you've probably done this about 10 times over, okay? But just, it's really good to see all of these little steps. And this is one that I think sometimes we forget about. What we do now is we say that this constant of integration, this e to the power of c, we're going to rename that as a different constant, which is big A. So we've got ae to the power of kt. So that's t minus 18. So now we've rewritten that, and it gives us an expression for the temperature. But we've got 2 things in here that we don't know yet. We've got this constant, and we've got this constant. So it's time to use the facts about the pie. And the first fact was that when the pie came out of the microwave, it was boiling. It was 100 degrees. That's the first one. And then the second one is that after 5 minutes, it was 88 degrees. So we're going to substitute those in now. So we have 100 is equal to 18 plus a e to the 0. That gives me a is equal to 100 take away 18, which is 82. So t is equal to 18 plus 82 e to the power of kt. And we know that the temperature is dropping, so k is going to turn out to be a negative number, right? So now we're going to substitute in that after, when was it? 5 minutes, the pie was 88 degrees, so still too hot to eat. 88 equals 18 plus 82e to the 5k, giving me 70 divided by 82 is equal to e to the 5k. I'm going to take logs of both sides. And you can see that this thing here is going to be a negative number because this is a fraction that's less than 1. So just think about your log graph. It looks like this. And we are, I don't know, somewhere close to 1, so we're about here. So this is 5k. K is then equal to 1/5 times the log of this. And we don't want to round that too soon. So what's k? Well, k works out to be negative 0.03164. Okay, right, so finally we've got our particular solution. And this is it here, 18 plus 82 e to the negative this That's my equation. Right, so the last thing I had to figure out is when did I get to eat the pie? Well, I waited until it was 70 degrees. Actually, that's a lie. I just ate it as soon as I could, but I suspect it was at around 70 degrees. I was really hungry. So we're solving now for 70. All right, so 70 is equal to 18 plus 82. I bet there's no one watching anymore. I think all of my MCA class will have gone, yep, we've done this before. Okay, but you should wait because at the end there's a really good GeoGebra graph coming up. Maybe something else. So 52 over 82 is equal to e to the power of this. And now I'm going to take logs of both sides. So t is equal to the log of 52 over 82 divided by negative 0.03164, which is 14.39, and that's in minutes. So what time did I eat the pie? Where's the COVID tracker diary thing? Right, I went into Gyp Street at 4:11, and the pie magically went in and out of the microwave all at 4:11. Okay, then what happened? There's the pie, and then I drove home, but the time started when I bought that pie at 4:11. So I ate the pie 14.39 minutes after I bought the pie. So I ate the pie at 4:25 p.m., which is way too late to be having lunch. So I'll just leave you with one last thing. First of all, here's the graph from GeoGebra. Okay, and secondly, here's the video. Let's see if this is going to work. Maybe it's going to work, maybe it's not going to work. No, I don't think this is going to work. Never mind. Okay, there's the GeoGebra. And remember, always blow on the pie. Thanks for watching.